Hi ladies, in this video we're going to go through 5F, which is expanding brackets. So expanding just means expanding and factorizing. So you won't see factorizing for a while. So we're just going to focus on expanding, and expanding just means you're getting rid of or eliminating brackets. So you can see here in the first dot point in the key ideas, we're getting rid of the brackets by expanding an expression or expanding an equation. And I'll show you in a second how to do this with a few questions, but basically these dot points go through how to expand, and it's called the distributive law. So basically whatever number we have in front of our bracket multiplies every term inside the bracket. So this A multiplies the B and the A multiplies the C. Now, if we've got a negative in there, the negative stays with the C. So it's kind of A times B, A times negative C. So you end up with AB minus AC. And then here's a question where it's being applied. So you can kind of see actually it's not being applied, it's being proved to you why it works. So instead of writing 27, they've separated the 20 and the 7. Okay, so 5 times, and then instead of writing 27, they've written 20 plus 7. And usually if I was to do 25 times 27 in my head, I would actually do it this way. I would say 5 times 20 gives you 100, and then 5 times 7 gives you 35, and you get 135. So I would actually use the distributive law to calculate larger numbers, and you probably do it as well without even thinking about, well, that's what I'm doing. But in algebra, we tend not to have numbers, we tend to have letters as well. So you need to understand how that works. Okay, so the process of removing brackets using the distributive law is called expansion. Okay, so we're all about expanding here. And when expanding, every term inside the brackets must be multiplied by the term outside the brackets. So remember that terms are separated by plus or minus signs. So the 5 multiplies everything inside the brackets. All right, so I put question 2 down. I don't usually start with the easy ones, but I thought this is just maybe a little bit of a confusing question, but so I just want to show you how it's done. So basically, the reason for expanding here, so we've got a rectangle that's been separated in 2 parts by this red dotted line, and this side here has got an X and a 4, and then on the other side we've got a 12, and this side is also 12, so I'm going to write 12 there. So if we look at the area of both shapes, here we're going to have 12 times x, which is 12x. And here we've got 4 times 12, which is 48. So your total area is going to be 12x plus 48. And basically what we have done is, if we were looking at the expanded form, we just did 12 times x plus 4. Okay, so that side there. But because we didn't know what x is, we leave it in terms of x. So this one here, we've got 8 times z, which is 8z, and 8 times 9 is 72. So your total area is 8z plus 72. But if we were to write that in what we call expanded form, that would have been 8 times z plus 9. Okay, so remembering that length times width, so z plus 9 on that other side. Then here we've got 3 times 3, which is 9. Then this spot here is 3 times a, which is 3a. And then this spot here, we've got 3 times b, which is 3b. And then a times b gives you ab. So if we were to write the area for this one, we would have, and depends how you want to write it, I'm just going to write it in the order that I did it, 9 plus 3a plus 3b plus ab. And it doesn't matter what order you actually write them in. If we were to write that in factorized form, and you don't have to necessarily know this at year 7 level, we would do our length, so 3 plus a times your width, 3 plus b, and that's what it looks like in factorized form, but we're not actually expanding brackets like that. All right, so moving on to question 3. So when you're expanding brackets, so, oops, come on, 6 times y plus 8, always draw your lines. I'm going to go blue. So we're doing 6 times y and 6 times 8 because so many people always forget to do the second term. So it's 6 times y plus 6 times 8. So 6y plus 6 times 8, which is 48. And we leave it like that. We can't do any more. We don't write 54y because they're not like terms. So we've got a y here and we've got a constant term. So it's just left as 6y plus 48. Let's do another one. So let's have a look at maybe G. So I'll do question G. What is it? 9 minus x. So again, doing your expansion. So 9 times 9 and 9 times negative x. So I'm going to write that down. Now, if you, because there's a negative there, you can put a negative first and then do 9 times x. So we've got 81 minus 9x. Or if you want to, you could do 9 times 9 plus 9 times negative x. And because it's a negative, I always put them in brackets. 9 times 9 is 81. 9 times negative x is negative 9x. So I think putting the negative here means we don't get confused. Sometimes students get confused with their negatives. But if you're okay putting your negative there, then put it there. Same thing. All right, let's have a look at question 4. So question 4 is quite similar. We've just now got a coefficient in front of our pronumeral. So I'll do a to begin with. So 10, 6, oops, got the 6. 6g minus 7. Okay, so we still do the expanding. So 10 times 6g. Now, I'm going to do it the way I would do it, because if this was a negative, then it gets really confusing. So 10 times, and then I'm going to put the negative 7 in brackets, 10 times 6g, so that gives us 60g. Okay, so 10 times 6 is 60, and then you've got the g. Then 10 times negative 7 is negative 70. Now, I'm going to do a question that's not on here, and I don't think it's going to come up. So I'm going to add a question in that's not on there. Maybe I'll do it in a different color. So let's say I had 2 negatives. So let's say I had negative 2 times a minus 3. So this is why I always use brackets. So negative 2, so if I'm expanding that, I've got negative 2 times a and negative 2 times negative 3. So negative 2 times a, and I'll put that in brackets, and then plus negative 2 times negative 3. So I've got negative 2a, and then I've got 2 negatives. So a negative times a negative gives me a positive. So I'm going to have plus 6. Now, if you wrote a negative here and got your negatives mixed up, that's where students often make errors, especially when they're starting out. So I often just do it this way. So I would always put a plus and then put your negative in and do that. So let's do another question from question 4. We'll do a negative one. Okay, so let's have a look. I think they're not all negative. So let's do E. So we've got 7, 8x minus 2. So we've got 7 times 8x, 7 times negative 2. So I would do 7 times 8x, do the plus, 7 times negative 2. Because that's effectively, that negative sign is attached to the negative, attached to the 2. So 7 times 8x gives you 56x. And then 7 times negative 2 gives you negative 14. So let's do another one. Let's do H. So we've got 4 times 5c minus v. So we've got 2 different pronumerals now. So draw that in. So we've got 4 times 5c plus 4 times negative v. So 4 times 5c gives you 20c. 4 times negative v is negative 4v. All right, let's move on to, let's have a look at questions 5. So 5, we've now got a pronumeral out the front of the bracket. Okay, so let's just get my pens ready. So 5a, we've got 6i, oh, we've got multiple variables. Okay, but it's done, the method's still the same. So we're multiplying the 6i by t and the 6i by negative v. So I'm going to write 6i times t. Make sure your handwriting is neat because we don't want to get our letters and our numbers and our multiplication signs mixed up. And then 6 times negative v. So 6i times t gives you 6it plus, oh, actually I've got a negative here, so I might not write the plus just yet. 6 times negative v gives you negative 6v. All right, let's do k. So 7k times 2v plus 5y. So again, we're expanding by multiplying both terms inside the bracket by 7k. So 7k times 2v plus 7k times 5y. So 7 times 2 gives you 14. And then we've got k and v. And then 7 times 5 gives you 35. And we've got k, y. Okay, so it doesn't matter about, you could add more pronumerals if you want. The process is pretty much the same, but as long as you take your time, you shouldn't make any errors. All right, now I put down question 6 because sometimes students have a problem with worded problems like this. So creating, I guess, a expression from a worded sentence, basically. So let's have a look at question A first of all. So a number x, okay, so we're going to write x, and you're probably like, x isn't a number, it's a letter, but remember that x represents a number, we just don't know what that number is. Okay, it has 3 added to it, so we're going to add 3, and the result is multiplied by 5. So when we get a result, we've got to give it a big hug. Okay, we'll put the brackets around it, and it's multiplied by 5. Now, we don't tend to write algebraic expressions like this. We would normally put the 5 out the front. It's kind of like if you went shopping and you wanted some bananas, you don't, well, not that you usually get your own bananas, but you don't go, I'll have bananas times 5. You go, I'll have 5 bananas. So the number kind of comes first. So remember, we don't say, I'll have sausages times 5, thanks butcher. You say, I'll have 5 sausages. So just putting that number first. All right, so question B. Let's have a look at that one. So a number B has 6 added to it, and the result is doubled. So remember, when something is doubled, it's multiplied by 2. But again, we put that number out the front of the bracket. So God, my 6 is looking like a B. So we don't have shoes times 2, we have 2 shoes. Okay, so remember the number goes first. All right. Question C, quite similar. Excuse me. So a number Z has 4 subtracted from it, so it's minus 4. And then the result, so we give it a hug, is multiplied by 3. So remember, we put the 3 at the front. And then lastly, a number Y is subtracted from 10. So we start with 10. So Y is subtracted from 10. And the result is multiplied by 7. So remember, we've got the 7 first. So 10 minus Y. When you're doing addition, the order doesn't matter, but subtraction does. Okay, so when it said Y Y is subtracted from 10. So it's 10 minus Y. So a bit of a hiccup there. All right, girls. Bye.